Hello everyone, welcome to Coders Camp. So we are the 17th day of April LeetCode challenge and the problem we are going to cover is number of submatrices that sum to target. So here given the input is a matrix, a two-dimensional matrix and a target value. So we have to find the number of submatrix that sums up to target. So let's understand this problem with an example. Here is our given input matrix and our target value is 0. So we have to find the number of submatrix whose sums up to 0. So now starting from the first value 1, and if you add 1 and minus 1 the sum would be 0. The same way if you add minus 1 and 1 in the second row the sum is equal to 0. Again if you add column wise 1 and minus 1 it is going to be 0, and same way the second column sums up to 0. Overall we got 4 submatrices. Also if you add the whole matrix the sum is going to be 0, which is also considered as part of a submatrix. So overall the number of submatrix whose sum is equal to 0 is 5. That is going to be our output. So how are we going to approach this problem? So if we want to solve this for a matrix, it looks big and difficult. So let's divide this problem into sub-problems and then solve for a bigger solution. So consider our matrix is only 1D, that is simply an array. So if you observe, this problem can also be said that find the sum of subarray whose sum equal to k. So we are going to have a similar approach in this problem as well. That is, we are going to calculate the prefix sum of each row and then finally arrive at our solution. So for example, if we are starting from our first element, the prefix sum is equal to 1. And if we are adding 1 and 2, the prefix sum is going to be 3. And again, if we are adding 1, 2 and 3, the sum is going to be 6. So now we definitely need a data structure in order to store the prefix sum and its occurrence. So I'll tell you why we need the occurrence later, but right now the data structure we are going to use is a hash map. So here in this hash map, the key is the prefix sum of each row and then the number of occurrence as its value. So now why 0? Because if we are considering the prefix sum of only one cell, which means in before the sum must be 0. So from 0, the sum of the first cell is going to be 1. So now why we need the occurrence? If suppose we are having an extra cell whose value is going to be minus 3, then the overall prefix sum is going to be 3, because the sum till 3 is going to be 6, and if we add minus 3 with 6 the sum is going to be 3. So instead of adding 3 and the occurrence to 1, we are going to update our table directly where the value is and increment the count to 2, that is increment the count by 1. So now our hash map will be updating with the occurrence so that it is easier for us to find the prefix sum occurred already in the matrix or not. The count of 3 is equal to 2 actually means there exist two subarrays whose sum is equal to 3. For example, 1 and 2 if you add, the subarray sum is 3, and if you add 3 alone or consider 3 alone as a subarray, the sum is again going to be 3. So which actually been identified by this table as count 2. So now the problem asked here is the sum of sub matrix whose sum is equal to target. So how are we going to do that? So if we are given an input matrix, we are going to calculate the prefix sum of each row in the matrix, and the prefix sum of this matrix is going to look something like this. So after finding the prefix sum, we are going to iterate through every subarray or submatrix and find the differences. For example, if we are having the prefix sum, we are going to subtract the second cell from the first cell and the third cell from the first cell and second cell from the third cell, so that we will find every possible prefix sum difference and find if there is any submatrix whose value is equal to target. So if we want to consider the iteration of all possible values in an array or a matrix, we either go for a brute force approach. If not, a very handy solution is sliding window. So here we are going to use a sliding window technique, which is gonna iterate or keep our window size between every column possible. For every row, it is gonna subtract the sum from the target and have the entries in our hash map. So as we enter the values in our hash map, we are going to keep track of a variable count, and the count increment every time it come across a submatrix whose sum is equal to target. So finally, we are going to return count as our result. So this solution may be a bit confusing, but you are going to understand it once you see the code. So let's go to the code now. So first I'm going to get my rows and columns as M and N. So I'm going to iterate through my row and column in order to calculate the prefix sum of each row. So now we have used the same matrix to calculate our prefix sum. So let me initiate a variable count, which is actually going to be our output. So in between, I'm going to write my sliding window code, so which is going to have its window space for every possible column. So also we are going to calculate the prefix sum between every row. So I'm going to have one more iteration for my rows. So here, before entering into my row, I'm going to declare my hash map to hold the prefix sums differences and the occurrence. And I'm going to have the default value that 0, 1. Also a variable sum to calculate the differences every time. So now after my row iteration, I'm going to calculate the sum. And I'm going to check whether my I is greater than 0, which means I'm not in the first column. In that case, I'm going to subtract my value with the previous column. If not, I'm going to subtract it with 0. So every time I find my sum, I'm going to increment the count by getting the values in my hash map. And once I incremented my count, I'm going to update my hash map with the new value. So yes, the coding part is actually done. So we are going to calculate the prefix sum and then iterate through every possible row and column using sliding window and find the differences of prefix sum and update our hash map. And once we find the sum minus target already present in hash map, then we are going to increment the count by the number of occurrences. And finally return the count, which is actually the number of submatrix whose sum is equal to target. So let's run now. So yes, let's submit. So yes, a solution is accepted. So thanks for watching the video. If you like the video, hit like and subscribe. Thank you.